Hello everyone, welcome back to my YouTube channel. So in this video we are going to understand EKS service. So EKS stands for Elastic Kubernetes Services. So basically what we are going to cover as part of this video. So the very first thing we are going to understand the workflow of EKS, like basically how we can interact with EKS and what all the core object or core components of EKS services. Then we are going to discuss about managed group, or I would say a worker node. Then we will also see the tools which we can use to set up a EKS cluster apart from AWS console. Then we will see a live demonstration where we will set up a EKS cluster. So let's understand and let's start. So what is Amazon EKS? So Amazon EKS is a fully managed service that makes it easy to run Kubernetes on AWS without doing all the heavy lifting yourself. What does it mean basically? So you are not going to maintain the most of the part of EKS cluster. The main part, if I would say, or brain of EKS, which is control plane, that is completely managed by AWS. So you are not going to manage. And also there are options where you can, if you want, you can. Otherwise, there are options as well where the node worker node is also managed by EKS. So we have a feature, or we have an option called managed worker node or EKS auto mode. So these are the options available as part of EKS services where you don't need to manage. Basically, you can focus on deploying your application or the pod management. So you can do. So when we set up a EKS cluster, basically we get two configuration options. So the very first is quick configuration option, which is with EKS auto mode, and the second option we get custom configurations. So let's understand about these two cluster configuration option first. Before that, let's understand what is EKS auto mode. So basically EKS auto mode is a new feature in Amazon EKS that lets you quickly create and run Kubernetes cluster with minimal configuration using AWS managed infrastructure and best practices. So what all the things you will get if you will create EKS cluster using quick mode or quick configuration option. So AWS automatically set up a VPC, networking, IAM, storage, monitoring. So a lot of things basically it is already created or set up by AWS itself. So before going to a detail in these two configuration options, let's go to AWS console. So let's see what all the options we have here first. So I'm on my EKS cluster. So I don't have any cluster for now. So if I'll click on create cluster option, so we have two options: quick configuration with EKS mode, and another is custom configurations. So in custom configurations, you are responsible to manage most of the things, because here basically you if you want to customize your VPC, IAM, EBS, a lot of things basically you can customize based on your requirement. But if you are using a quick configuration mode, then you can see you don't have much options. You have to just provide a cluster name, or then you have to select the IAM role. You don't have, you can create from here, and it will use a default VPC and all the subnets which is part of this particular VPC, which is default VPC. So there are, we can see lot very minimal options. So this is good if you are doing for a dev or test purpose, or you are learning from your own. In that case, that is option is good. And another option we have custom configurations, where you can customize the EKS cluster based on your requirements. So there are, you can see a lot of options we have here. So this is basically we generally use when we use a production level setup. So in custom configuration also we have EKS auto mode. So basically these are the worker node options. Like if you want, you can use EKS auto mode. So whatever the basically worker node in background, it is a EC2 instance. So those also managed by AWS itself. If you don't want to use, you can disable these options. So you have basically three configuration of option: quick configuration, custom configuration with EKS auto mode enabled, and custom configuration with EKS auto mode disabled. So we will see all these three options in detail in the presentation. So let me go back to my presentation. So before moving to a configuration options, let's understand the EKS workflow. So first thing, we have to create a EKS cluster. So basically what we are going to create, so we are going to create a control plane. So this is the brain of our Kubernetes cluster, and then we create a worker nodes where basically we run our applications, and from our client machine or a local machine basically we connect to our EKS cluster and we manage our application. So this is very simple workflow, but in background lot of services are going to use. So actually we will not go in that depth because that is not necessary, but you should know what all the components we will get as part of control plane and what all the components we will get as part of worker node. So those you should be very you should be familiar with this. So let's understand what all the components we will get when we create a control plane. So EKS control plane is the brain of your Kubernetes cluster when you are using Amazon EKS. So the component, very first and important component is API server. So basically API server is a kind of a communication hub. So when we interact with EKS cluster from our local system, we generally interact with API servers. Then we have etcd. So this is highly available key value store. So where we basically all the configurations or all the state of your EKS cluster will be stored here. Then we have another component which is scheduler. So this basically helps us to determine on which node we have to run our pod. So basically it will continuously check the health of worker nodes, and based on the available or healthy nodes it will automatically allocate that particular node to run our application pod. Another component we have here is control manager. So control manager runs various controller that continuously reconcile the cluster's current state with its desired state. Like whatever the current state of the EKS cluster is, that and whatever the desired state we want. So basically that match the both the status, or I would say it basically keep the both the state in a same level. So like if you want, like if we have mentioned, okay, I want two replicas of my application pod, in that case what this will do basically, this is the desired state, because we have asked, we have a desire, like we want two pods to be always running. So that part basically handled by a control manager. Then another component here we have a kube proxy. So a network proxy that runs on each worker node, handle network rules and allowing communication between pod and services. And one more important component which I have not mentioned here, which is kubelet. So that is again an agent which generally used to manage our Kubernetes pod, or we can say a daemon. And Docker daemon also I have forgot to mention here. So another two components, kubelet and daemon as well. Now let's understand what all the worker node options we have here. So when we use a EKS cluster, we basically use four types of worker node. So the very first is EKS auto mode, another we have EKS managed node, and then we have self-managed node, and another we have AWS Fargate. So basically EKS auto mode, basically if we are using a node management with the if we are creating an EKS cluster with EKS auto mode enabled, then it is fully automated and AWS will be completely manage your operating system, like what all the AMIs it will be used, or if there any upgrade or patching. So everything basically managed by, all the maintenance works will be managed by AWS itself. But if we are using EKS managed node group, so again here AWS manage all these things, AMIs, updates, patchings. Then we have self-managed group, self-managed or node. So here basically we have to manage everything like operating systems, the AMI, patching, everything basically we have to manage here. Then another worker node option here we have AWS Forget. So this is basically a serverless. So like if we want to go with a serverless options, then we can go with AWS Forget options. So here we don't need to manage any node. Everything will be managed by AWS. If we talk about a compute control, the features, so you can see in EKS auto mode, it's a high level via node classes, for instance. So I have just mentioned the details. If you want, you can go through all the details. I just want to highlight what all the node options we have in EKS. So we have four options: EKS auto mode, EKS managed node group, self-managed node, and AWS Forget. So now let me quickly in understand in a depth basically all the three options which we have discussed here. This quick configuration, custom configuration with EKS auto mode enabled and disabled. So the very first thing we are going to see quick configuration with EKS auto mode. So here we are basically going to discuss about this option. Okay. So this is basically a fully automated simplified setup by AWS console using AWS recommended default. So like what all the AWS recommended, like if it will use a worker node, for example T3 or .medium or maybe a large. So we are not sure, but you don't need to manage. You can simply go and set up the EKS cluster for you. So it is basically best for or suitable for beginners, or if somebody is going to perform any kind of POCs, then in that case they can go with these options. Developers who don't want to manage infrastructure, so they can go with these options. Now if we talk about pros and cons, so this is basically obviously fast and easy setup because we are not going to worry much about the infrastructures and permissions and all. And here we have to basically give a minimal input. So we have to, as I told you, we have to mention few details like cluster name, which Kubernetes version, and the IAM role, node IAM role, and you are good to go. And if we see a console, here we have a limited customization option, so we cannot use this option for production level. Now let me go to another one. So custom configuration with EKS auto mode enabled. So here basically you configure a networking, IAM and cluster settings manually via console, or you can use any command line tool which is eksctl or Terraform. But still we can use the auto mode for managed EC2 instances. So you can customize most of the things here. But if you are going with EKS auto mode enabled, in that case the node management will be handled by AWS. So it is best for production workload because we are going to set up most of the things from based on our requirement, like networkings and IAM and identity and access management. So all those things basically we are going to set up here. Now if we talk about pros and cons, so here we have a full cluster control plus benefits of auto mode as well. It supports Terraform, eksctl. We will discuss about this. This is the utility which we use to create a EKS. We will go with this in later slides. And we can use a custom node pool as well if we want. So we have a lot of options here. And if we talk about cons, so there are not much cons here basically. So it require more effort and expertise because you should be familiar with networking part, identity and access management part, and like you should be, if you are going to write a YAML file, then you should know how to write it. So a lot of things basically you have to understand before going with these options. So that's why I have mentioned here the slower setup than quick config. So if we compare with the first option, then obviously it is little slow to configure. Now if we talk about a custom configuration with EKS auto mode disabled. So this is the traditional method, like we are going to manage everything manually, including the worker node. This is best for advanced use cases with strict customization. Non AWS CNI custom AMIs, like if you don't want to use AWS provided Amazon machine images, then in that case you can go with these options. Or if you have any compliance issues, in that case you can go with this option. So here basically we have to put a lot of effort to set up EKS clusters. So here you will have a maximum flexibility and control, because everything you are going to set up, so obviously you will have a full access. And if we talk about a cons here, so highest operational overhead, obviously, because lot of things you are going to manage, lot of resources, so it is overhead for the users who is going to create with these options. Require deep EKS and Kubernetes expertise as well, and here no built-in node automations. So these are the cons basically. So if you are learning EKS, I would suggest go with first option, which is quick config with EKS mode, EKS auto mode. So you can go with these options and you can do your hands-on. Okay, now let's talk about pricing basically. So how EKS basically charge you. So if we talk about EKS cluster control plane, so this is basically a charge $0.10 per cluster and per hour. Nodes, if we talk about nodes here, basically it's applied regardless of compute options, EC2, Fargate or Outpost. So in general, you will be charged for $0.10 per cluster per hour and if you are using a standard support or a extended support, for that charges will be separate. So you have to keep in mind. So in general, if you are doing a POC or you are learning, then you can assume this much you have to pay per hour for control plane. It is not a free. Now if we talk about a worker node, so if you are going to use Amazon EC2 instances, then you manage EC2 based worker nodes. Definitely we have to manage, and it's based on instance type and uses. So like if you are going to use T3 medium, large, like whatever the configuration compute options you are going to choose to create a EC2 instance, accordingly you will be charged. It includes basically EC2 cost, EBS, data transfer, and optionally a load balancer. So a lot of cost will be included here. If another worker node options here we have is AWS Fargate. So this is a serverless container, so you don't need to manage infrastructure. So here again you will be charged based on the virtual CPU and a memory. So the virtual CPU, the cost is $0.04048 per hour, and memory it's almost similar per GB per hour. So accordingly you will be charged if you are using AWS Fargate, which is serverless containers, and it is built per second with, so basically every second you are going to charge if you are going to use. That's why the per hour cost it's approx this much. And again the pricing part basically always vary based on the regions where you are provisioning the resources as well. Another option here we have is AWS EKS auto mode. So auto manage cores and add-ons and nodes using optimized EC2 instances. So here basically a control plane free plus EC2 instance cost. So as I told you, control plane is not free or free, it is cost you but very less. Minimal cost you have to pay, and along with the EC2 instance which you will run, for that you have to charge. And again whatever the images you are going to use instance basically, for accordingly you are going to charge. And another thing, additional AWS services for that, like EBS volumes which you will use to store your data, load balancer, CloudWatch for monitoring, KMS for encryption, data transfers across availability zones. So all those things will be the additional cost. Now let's talk about the options for creating a EKS clusters. So I have mentioned here 6 options here. So the very first is through the AWS consoles, which we have already seen here. Another here we have is AWS CLI. Then we have eksctl. So this is the option which we are going to use for the demonstration as well. So this is basically a fast setup. It generally took around I would say 25 to 30 minutes to set up a EKS clusters. And here you have an option for a node, worker node as well. You can use managed, forget or self-managed. Then we have a cloud formations. So we are here basically we have to write a ML file or JSON file, and like it is infrastructure as a core basically, like similar to a Terraform. So one more thing here. So when we create a EKS cluster using a eksctl utility, in background basically this will launch a cloud formation. We will see in a demonstration. So in background basically when we run the command from using eksctl, the cloud formation task stacks basically will be executed. Then we have Terraform and cloud deployment kit. So all these 6 options we have to create EKS cluster. So this is descriptions like features, what all the things we will get as part of EKSctl, AWS CLI and kubectl. So these are the 3 I would say prerequisites which you should have in your local system when you are going to use or you are going to create EKS cluster. So everything, every utility or every client command line tool basically works separately, or I would say they work together, but the purpose of each utility is different. So the primary focus of EKSctl is EKS cluster lifecycle management, like you have to create, delete or update. And AWS CLI basically used for general AWS resource management, and kubectl basically definitely used for pods management or application object or Kubernetes object management basically. And if we talk about level of abstractions, so here we have high, medium, and again here is high. Target audience, if we talk about, so this option or utility will be used by EKS administrator or DevOps engineer, AWS CLI, AWS administrator or developers, and here kubectl generally used by developers of DevOps engineer, because this utility generally used to manage your applications inside a Kubernetes cluster. And if we talk about the scope, so EKSctl basically is AWS specific. So because this is created by AWS and I think members, if I can remember correctly, so you can create Kubernetes cluster only with AWS, under the AWS. If you want to create a Azure based Kubernetes cluster, you can't use this utility because this is specific to AWS only. And if we talk about AWS CLI, so all the AWS services you can manage from AWS CLI. Then we have kubectl. So kubectl CTL utility we can use in any of the Kubernetes cluster, either it is Google, Azure, Microsoft Azure or AWS. If we talk about interactions, so like all these 3 utilities basically directly interact with AWS API, or I would say Kubernetes API. Sorry, no, sorry, wrong. So basically, EKSctl interact with AWS APIs via cloud formations, which we are going to see in a demonstration as well. And here AWS CLI interact with AWS APIs directly, and kubectl directly interact with API servers for our application management. So now let me do one thing. Let me quickly go to Kubernetes services and we will create a Kubernetes cluster. So before that, let me open my wiki page. So there actually I have mentioned all the tasks which we needed. So we don't need many things here basically. So let me go to my wiki page. And here I'll go to AWS documentation. So here I have step-by-step guides basically. So before you start setting up a EKS cluster, you should have all these 3 utilities in your local systems. Otherwise you will not be able to create a EKS cluster. So you should have all these 3 utilities. So let me open my command prompt. So actually I have already set it up. It is very simple. So if I search for AWS here, So we are getting this option. It means AWS utility is installed. If I'll search for eksctl, so we are getting these many options. It means it is installed. And if we kubectl, so this is also we are getting a response. So I already created, or sorry, or I would say set up all these three utilities in my local systems. Next thing, you need an AWS account with sufficient permission. So here basically I just want to talk, like I want to tell, like we should have a IAM user which should have a permission to create a EKS cluster. So for that, what I already have one user. So let me just quickly show you. So if I'll go to users, so we are going to use this demo user as part of EKS cluster demonstration. So I have this user, and for this user I have assigned administrator access, like complete access, but this is not recommended. This is a simple demonstration, so I have not specified multiple permissions. But again, if you are using in your production level or organization, you have to follow a granular access policies always. So let me do one thing. Let me get a access key here. So let me first deactivate the existing one, and let me delete this as well. So what I will do, I will create a access key because we need to authenticate to AWS from our local system. So for that we need a access key. So let me go and create a access key. In use case, I will select command line interface, and let me hit on create next and create access key. So let me copy the access key here, and I will open my notepad. Okay, so let me copy the access key and password as well. So when you create an access key, always keep a password in a safe place, because you cannot see this password again if you close this window. So let me click on done. We can download as well, but I have not downloaded it. It's fine. So now let me go to my command prompt here. So let me clear the screen. So let me go to my documentation. So first thing what we have to do, we have to authenticate with AWS. So for that, what will be the first command? So we have to run first AWS configure. So here basically we are going to use AWS command line tool. So now let me copy my access key, and let me copy my password as well. Okay, reason I want in AP South 1, so it's fine. Note output I want in like by default utilization, so it's fine. So now we are authenticated to AWS. So so now the next thing what we have to do, now we need to create a EKS cluster. So this is the command basically which we will use. So if you are not sure what the command you need to execute, you can always use help command, so which is eksctl --help. So you will get all the options whatever you want to use. Okay, so let me go to my documentation here. Let me clear the screen first. So let me copy this command. So the very first thing, we are going to create a EKS control plane without a node group. Node group we will create separately. So why? Because we want to see what all the default things it will be created when we run this eksctl command. So let me copy this command. So let me explain this command as well. Let me paste it here first. So the eksctl is a command line utility, and we are going to create a cluster, and this is the name of our cluster, which is dev-eks-cluster, and the version we are going to use 1.33, which is the latest Kubernetes version, I think so. And the region, I'm going to use my region where I want to create this EKS cluster, which is AP South 1, and I don't want the node group, so I'm going to with ---- without node group options. So let me hit on create. So as soon as you hit on create, you will see it start deploying a stack. So stack basically it's a cloud formation. So if I'll go to my AWS console here, and if I'll go to cloud formation, so you can see it is created a stack with the name of eksctl dev-eks-cluster, which we are going to create. So if I will open it, and let me minimize this, and if I'll go to events, so here we can see what all the things it is going to create as part of EKS cluster with this options eksctl command line utility. So it is going to create a net gateway, it is going to create a public subnet, then it is going to create a private route tables, public route tables, ingress node groups, control plane itself. uh, so lot of things basically it is going to create. BPC also, you can see BPC gateway attachment, so subnets. So basically most of the networking parts it will be handled by this utility. You can see BPC, internet gateway, service roles, everything will be created by this command itself. So that's why it is very quick. If you are going to use, or if you are going to learn basically EKS cluster, I would suggest go with this option. So by default most of the things will be created without any depth knowledge. So it will take a couple of minutes to create a EKS cluster. So what I will do, I will stop the video. Once the EKS cluster creation part will be completed, I will resume back. So now it is completed. We can see a message here, EKS cluster, the name of the cluster in this particular region is ready. And there is one thing we can see here, we are getting a warning here like this OIDC is disabled. So what is OIDC? Basically OIDC stands for OpenID Connect, which generally used by our application pod. Like if our pod want to access S3 services or database, in that case these OpenID Connect basically use. So let me do one thing, let me go to my second step. Before going to a second step, let's quickly verify what all the resources it is created. So if I go to a cloud formation and stack, so here we can see all the resources name which is created as part of EKS cluster setup. So we can see a lot of resources has been created as part of our EKS cluster setups. So if you are going to use custom configuration setup, it means you are going to manage these many resources, like you have to manage or you have to create. But in production level generally we use a custom configuration setups only. So let me go back to my here. So the next command we are going to, basically we are going to associate a open OIDC provider for IAM role for service accounts. So if we will associate this OpenID Connect from our EKS cluster, it means the application pod can access the AWS services like S3, CloudWatch, EBS, and what all the services it want to use using the IAM role for service account, IRSA in short form which we called. So let me copy this command and let me run it. So before running this command, let me quickly show you one more thing here. So if I'll go to my IAM role, because this OIDC is a part of identity and access management. So if I'll go to here, and if I'll go to identity provider, so if you can see we don't have any identity provider here. So now let me run this command. If I correctly remember, this will be associated here itself, like we will see here. So let me run this command first. So it is created a IAM OpenID Connect provider for cluster. So if I go here and let me refresh it. Okay, so we can see OIDC.EKS and this is the region. So basically that particular OpenID Connect is associated or added in our identity and access management. So with the help of this OpenID Connect, our application can access AWS services using the IRSM. I think I always forget this name. uh, IRSA, sorry, internet, sorry, IAM role service account. Okay, now here we have another option. If you want to manage your worker node, you have to always create a EC2 key pair, so you can manage your on your worker node. But this is just a simple demonstration, so we are not going to use create a EKS key pair. So we are going to use a default option one, which is without volume and add-ons. But if we are going to set up like in another video, basically we will set up a little complex EKS clusters. In that case we will use add-ons as well. So like if you can see here, external DNS, AGS access, ECR access, like obviously we need a doc container images to access our to deploy our application. In that case we have to we should have permission to EC2, sorry, ECR registry as well. So these are the roles basically which we are going to create as part of this add-on. But for now we are not going to go with this option 2. We are going with option 1. So here what we are going to do, we are going to create a node group as part of our EKS clusters, and we are going to add our node group in EKS in our EKS cluster. And the type we are going to use t3.medium, and we are going to create one worker node, and the desired we need a minimum 1 and maximum 2. And verbose basically I have already basically put to check the logs in a console itself, like in command line itself. So let me copy this and let me go to my command prompt. Okay, before that let me quickly check the cluster. So eksctl get cluster, so we can see the cluster name, region, and create it true. Okay, now let me clear the screen and let me run this command. So it start creating a worker node, and again it will take at least 5 to 10 minutes to create a node group. And if you see the worker node creation is taking a lot of time, like it's taking more than 15 or 20 minutes, then you have to always check your service quota, like if you are allowed to use these instance type like t3.medium, which I have used, because they required more virtual CPUs. If you are not allowed in your AWS account or region, then you cannot create a worker node, because we need at least 2 virtual core CPU to create or to run our worker node or applications on EKS. This is the basically a minimum, but for maximum there are no limits. Based on our application requirement, we can use n number of virtual CPUs. But if this particular process is getting stuck or it's taking more than 20 minutes, it means you have to always go and check your service quota, like how many virtual CPUs are allowed as part of your AWS account. So let me go to my it is running, it is not created yet, but before that let's quickly go and check what it is going to do. So let me again go back to my CloudFormation. So whenever we run a eksctl command, it is always used a CloudFormation in background. So you can see it is created another stack with the name of node group. And if I'll again go back to events here, so you can see here basically it is not going to create a lot of resources, because we are just simply going to create a managed node group. And basically these are the EC2 instances. So if I'll go to EC2 and if I'll go to instances here, so you can see the name here is dev-eks-cluster, and this is the basically EC2 instance which will run as a worker node. And we have defined the T3 minimum and maximum, because these EC2 instance run as part of our auto scaling group. So if I'll go to my auto scaling group, so you can see the worker node here. So here we have a desired capacity 1, which is minimum 1 and maximum 2. So these EC2 instance which run as a worker node, it always part of auto scaling group. So let me quickly go. Okay, still it's running, and as soon as the node group will be created, we can see in our EKS cluster as well. If I go to EKS cluster, and if I'll open it, so if you will go to under compute, so you can see a node group here. So the node group name is app-node-group, which we have given. So you can see the status is also active. I think it's running. Okay, so it is completed. You can see the node group has been created successfully. So if you just want to verify from the command line, you can simply run eksctl get nodes. Sorry, not nodes, it's, let me quickly check the command eksctl get node group, sorry, node group. Okay, eksctl get node group. I misspelled, I think. Let me copy this command and hyphen cluster name also we have to specify, which is, let me copy my cluster name from here, which is dev-eks cluster. Okay, so I think it's only cluster. Okay, so here we can see the instance type, the image ID, status, minimum size, maximum size, desired type. So all these things, it means we have successfully added our worker node in EKS cluster. So I hope it's clear, like how we can create a EKS cluster for learning purpose or POC purposes. Like we should not use, or we should not go with custom configuration options, because for that you have to manage a lot of things. For initial or for the starting point, always use these commands line utility, so it will quickly set up EKS cluster for you. And one more thing, once you're done with your work, always delete the EKS cluster, otherwise they will charge a lot of money as well. So I hope it's clear. In case if you have any issues or doubt, you can ping me over comment as well. I will put these commands in description about in description as well. So if you want to do a hands-on, you can do that as well. So that's all for today. See you in next video. Thank you so much.